Hi there, everybody. I hope you're doing well today. This video is going to continue our crash course on logic by talking about some forms of argument that are rather common and that you'll likely run into quite a bit if you keep a lookout for them. So in the video, we're going to start out by talking about the relationship between validity and argument form. Then we'll introduce 4 common valid argument forms, 2 common invalid argument forms, and then we'll discuss some common inductive forms. So remember that an argument will start with various premises and make an inference to a specific conclusion. The premises are the statements that are meant to support or convince you of the conclusion. Now, oftentimes we might try to evaluate whether the premises or the conclusion are true or false, but another thing we might want to evaluate is the inference. And when we do that, we are evaluating the logic or reasoning of the argument. And there's 2 standards we can use, remember. In deduction, we ask, do the premises give conclusive support to the conclusion? Whereas in induction, we're not looking for whether there's a guarantee. We're asking, do the premises give probable support to the conclusion? Now, in deduction, when we evaluate the logic of that argument, we're asking if the argument is valid or invalid. And a valid argument is one where if its premises were true, then the conclusion necessarily must be true as well. Another way of saying the same thing, remember, is that a valid argument is one where it's absolutely impossible for all the argument's premises to be true while the conclusion is false at the same time. Now, last time, we talked about one way to test for validity or invalidity. We talked about the imagination test, where you imagine that all the argument's premises are true, even if you know that they aren't, and then you ask yourself, well, when I'm imagining that those premises are true, could I simultaneously imagine the conclusion is false? And if you are able to, well, that shows that even if the premises were true as you're imagining them, that wouldn't guarantee the conclusion, and so the argument is invalid. But if the answer is no, that means if the premises were true, like you are imagining them to be, then that would guarantee the conclusion and the argument is valid. If you want to review those ideas of validity and the imagination test in a bit more detail, go back to the previous video. In this video, I want to clarify this sense in which validity is a matter of the form of the argument rather than the content of the argument, by diving into some more detail about what I mean by the form of the argument, how to identify that form, and how it helps us recognize validity or invalidity. So let's consider a couple arguments here. Let's call this one the passport argument. If Jane's passport is expired, then she isn't allowed to travel out of the country. Jane's passport is expired, therefore Jane isn't allowed to travel out of the country. So we discussed this in the last video and we determined that the argument is valid because if we imagine all the premises are true, well then that would guarantee that the conclusion would have to be true as well. Compare that to an argument not about traveling or about Jane, but just about the weather. This argument says, well, if it's raining outside, then the streets are wet. It is raining outside, therefore the streets are wet. So this weather argument is also valid because if those premises were true, then they would guarantee that the conclusion would be true as well. Now, the arguments are clearly about different topics. One is about people and traveling and passports, the other is about weather. But nonetheless, the arguments look similar in some way, look very similar, despite the fact that they're about different topics. If you've noticed that, the similarity you're probably noticing is the fact that they have exactly the same form or structure. And it's that form or structure that makes these arguments valid. So these arguments are valid for exactly the same reason, due to having the exact same form. And so if we can recognize that form, it gives us another way to see why certain arguments are valid. So I'm going to try to develop that a little bit and help you recognize what the form is here, and hopefully give you some tools that might help you recognize the form of other arguments as well. So notice, in that first passport argument, there's some component statements that you see come up multiple times. One of the statements is this idea that Jane's passport is expired. In premise 2, you see that statement all by itself. In premise 1, you see that statement as one part of a bigger statement that's known as a conditional statement. It says if one thing is true, then the other thing is true. The if part is the antecedent, anti, think before. The then part is the consequent, literally the consequence of the earlier part. The other statement here is that Jane isn't allowed to travel out of the country. It occurs by itself as the conclusion of the argument, but it also occurs as a smaller part of the bigger statement in premise 1. It occurs as the consequent of that conditional. In mathematics, you have this idea of variables, A's, B's, and C's, that you can input different numbers into that can stand for various numbers. Well, we can use those variables here to stand not for just numbers, but for statements. And so I can replace the same statement throughout this argument with the same variable. And so when I replace Jane's passport is expired in the conditional of premise 1, I get this. And then in premise 2, since I see that same statement, I want to replace it with the very same variable, A. And now since I have a different statement in the consequent, I want to make sure I use a different variable. We'll just use B. But now since the conclusion has the same statement all by itself, we want to again make sure we use the very same variable. Now compare this to the weather argument. I get the weather argument just by putting a different statement in for those variables. For the A, I put it's raining outside, and for the B, I put the streets are wet. Now when I replace those with variables, notice the passport argument and the weather argument have exactly the same form. So we have variables to stand for each of the statements, and then we have some logical language, the if and the then for the conditional. Now, that form of argument is deductively valid, and since validity is determined by the form of the argument, that means every single argument that has that form is going to be valid. It doesn't matter what you put in for the A or the B. It doesn't matter if you put in claims about passports and travel, about weather, about politics, about philosophy, about science, about history, about biology, about art. It doesn't matter what you put in for A and B. The argument will always be valid. So if you can recognize that form of argument, then when you run into an argument with this very same form, you will immediately know that it's valid without having to go through the imagination test. And now, I chose this form of argument because it's a very common form of deductively valid argument form that you'll run into quite a bit if you just look for it. It's what philosophers call modus ponens. But there's several other valid forms of argument that are incredibly common if you look out for them. So one other one that I will discuss is modus tollens. This form of argument starts out very similar to modus ponens by saying if A then B. We have this conditional. But now in the second premise, instead of asserting A, this argument will claim that the second part, the consequent, is not true, so not B. And given that the second part is not true, it will conclude that the antecedent is also false. So here's an example. If it's raining outside, then the streets are wet, but when I look outside, the streets are not wet, and so I conclude that it is not raining. As I mentioned, just like modus ponens, this argument form is valid, and so any argument with this form is going to be valid, whether it's about the weather, about politics, about religion, about mathematics, about philosophy. Doesn't matter what you put in for the A or the B. So notice in the example, the statement it's raining outside is put in for the A, but notice in the conclusion, that statement also has a not in there, and the statement that's input for B is the streets are wet. But yet again, in the second premise, we have that logical word not added into the statement. Another common form is disjunctive syllogism. This claims, look, one of two options has to be true, either A or B. Well, B isn't true, so we conclude that A must be true. So as an example of this, think Ada must be at work or school. Ada is not at school, and so Ada must be at work. So the Ada must be at work is just input for the A, and then Ada must be at school is in for the B. Notice, of course, in the first premise, each statement is connected into a larger statement using the logical word or, but then in premise 2, statement B has the logical word not added to it. Whenever you run into this form of argument, yet again, it will always be valid. Lastly, hypothetical syllogism. It says if A is true, then B is true. So it looks very similar to modus ponens and modus tollens so far. But now in premise 2, it's going to claim, well, if that second thing is true, then a third thing is true. So we have a second conditional. And now by creating that chain, we can thereby conclude that if the first thing is true, then the third thing has to be true as well. Here is an example. If Monday is a holiday, then work will be canceled. If work is canceled, then the employees will be happy. And so we can conclude that if Monday is a holiday, then the employees will be happy. So notice, for the variable A, we just put in Monday is a holiday. For variable B, we put in work will be canceled. And for variable C, we put in the employees will be happy. Since it has the hypothetical syllogism form, and hypothetical syllogism is always valid, we know that this argument about holidays and work is also valid. And any other argument with this form will also be valid, whether it's about work, politics, religion, art, history, science, doesn't matter. So those are a few deductively valid forms, but there's also some commonly used invalid forms that you should also watch out for. And you'll probably see these argument forms mistakenly used quite a bit, since people make these mistakes quite often. One of those invalid forms is affirming the consequent. So it starts out with a conditional statement again, if A then B. But then it affirms this consequent, the B part, and then says, so the first part, the antecedent, must be true as well. Here's an example of that. If it's raining outside, then the streets are wet. The streets are wet, therefore it must be raining outside. It's raining outside is input for the variable A, and the streets are wet is input for the variable B. Since this argument matches the affirming the consequent form, we know that it's invalid. Another invalid form of argument that's really common is denying the antecedent. It says if A then B, so it starts out with a conditional again, but then it says A is not true. It denies the antecedent, and it thereby concludes that the consequent is also wrong. So here's an example. If it's raining outside, then the streets are wet, but it's not raining outside right now, therefore the streets are not wet. Well, that doesn't guarantee the conclusion, because even if raining is one way for the streets to be wet, this argument leaves open the possibility that there could be other ways for it to get wet. A fire hydrant breaking, someone washing their car with a hose, getting the streets wet. And so even though the antecedent is false, we cannot conclude that the consequent is also false. So raining outside is the A here, the streets are wet is the B here. And since this argument matches this denying the antecedent form, which is invalid, we know that the reigning argument here is also invalid. So being able to recognize these 4 common deductively valid forms, these 2 common invalid forms, is another way for you to very quickly determine that some arguments are valid or invalid. Of course, it's not always going to work, because not every argument is going to match one of these 6 forms that I've given you so far. So if you run into an argument that doesn't match, then you'll have to use that imagination test instead. But what about inductive arguments? What kind of forms might they have? I want you to be aware of 3 common forms. First is enumerative induction. So enumerative, just think like enumerate or number. It comes up with a list of examples. So an example of one thing that has a certain feature. A second example of that kind of thing that has that feature. And then you continue the list. A third example, a fourth example, a fifth example, going on. Until finally you get to, well, given all those examples that I've listed, you might conclude, well, probably all of the A's have that feature. Or at least maybe the next A will have that feature. So an example of this is the first penguin I saw was black and white. The second penguin I saw was black and white. The third, the fourth, the fifth, the sixth penguin. Until eventually I might conclude, well, probably all penguins are black and white. Or at least the next penguin I see will probably be black and white. So the list of A's here are the various penguins, and then being black and white is the feature. Another common inductive form is argument from analogy. So this argument starts with an analogy. It compares 2 things. It says A is similar to B in some ways. Well, I know that B has a certain kind of feature, call it F. Well, given the analogy between A and B, and I know that B has that feature, I might conclude, well, A probably has it as well. So let's consider a concrete example. You might make an analogy and say, look, the car I'm buying is similar to Jane's. Maybe they're both Honda Civics. And Jane's car has been very reliable for her. Well, given the analogy, the similarity between the car I'm buying and Jane's, I might thereby conclude that my car is likely to be reliable as well. So the car I'm buying is A, Jane's car is B, and the car's reliability is the feature that I'm utilizing in premise 2 and the conclusion. Another common form of argument is abduction. Sometimes this is just called inference to the best explanation. And that's because it starts by observing that some surprising thing is true or has happened. And then you start to try to come up with explanations for why that thing is true or why it happened. And maybe you notice that some of these explanations are better than another, and you realize, hey, look, here's the best explanation I can give for X, this surprising thing. And given that this is the best explanation, well, probably it's true. So here's an example. Imagine I'm playing with my kids and all of a sudden my daughter's toy robot stopped working unexpectedly, so surprisingly. And then I start to think, well, why could that be? And I think, well, look, maybe dead batteries is the best explanation I can come up with for why the toy stopped working. And so I might conclude, well, probably the toy's batteries are dead. And given this kind of reasoning, that might suggest to me I should first, given that this is the best explanation and it's probably the problem, I should first try to replace the batteries before I start opening it up and looking at wires, for instance. Notice the fact that my daughter's toy robot stopped working is the surprising thing that happened. The idea that the batteries are dead is the explanation that's given and thereby inferred from this fact. Now you might wonder, how do we decide whether or not an inductive argument is strong or weak? Well, evaluating that is much more difficult than evaluating deductive validity. So notice with deductive validity, I said modus ponens is valid, and affirming the consequent is invalid. But for the inductive forms of argument, I didn't say enumerative induction is strong or weak. And that's because inductive strength comes in degrees. An argument can be stronger or weaker. Maybe the premises make the conclusion 97% likely. Maybe they only make it 75% likely. But deductive validity doesn't come in degrees. It's either valid or not. An argument can't be a little bit valid or more or less valid. It's valid or it's not 100% or nothing. Similarly, a deductively valid form like modus ponens is always valid, regardless of the details. You don't need to know anything else. If an argument matches the form modus ponens, it is valid. But general inductive forms like enumerative induction, argument from analogy, and abduction, sometimes that argument will be strong, sometimes it'll be weak. It depends on the details. For instance, in enumerative induction, it might matter, well, how many examples do you have? Does your numbered list of examples, do you only have 3 examples of penguins? Well, that's not particularly strong. If you have thousands of examples, that's a bit stronger now. So in the sciences, this is the idea of having a good sample size, for instance. In the case of argument from analogy, whether it's strong or weak is going to depend upon how close that analogy is and how relevant it is to the feature you're inferring. Something else that's relevant here is the fact that a deductively valid argument will remain valid no matter how much additional information or premises you might add. So you take modus ponens, you add a third premise, a fourth premise, a fifth premise. It's still going to be a valid argument. But in the case of induction, when you add new information or extra premises to an argument that was strong, well, that new information might end up weakening the argument. So when you're considering an inductive argument, you want to make sure you're not missing any critical information, that you have all the evidence available to you. Otherwise, you might be misled. All right, so what have we learned in this video? We learned how to better understand the idea that validity is a matter of an argument's form rather than its content. You learned 4 forms of argument that are always deductively valid. You learned 2 common forms of argument that are going to be deductively invalid. You learned 3 inductive forms of argument that you'll often encounter and use yourself. And we learned about some of the difficulties that come with evaluating the inductive strength of an argument as opposed to talking about validity. So that's all for this video. See y'all next time. Bye-bye.